All right, chapter 8-4 talks about angles of elevation and depression. And really what we're doing here is we're taking what we looked at in section 3 with SOHCAHTOA, using those trig functions, and putting them into some context, talking about how we can use trig, SOHCAHTOA, to find distances, heights, using angles of elevation and depression. So let's go ahead and start by defining those. The first term is an angle of elevation. And an angle of elevation is the angle formed by a horizontal line and the line of sight to an object above the horizontal line. So when you think about angle of elevation, think about typically you consider it with eye level. So if you were looking straight out eye level and then up to look at an object, that would be your angle of elevation. The change from straight out ahead of you to up until you spot your item. And you can see that over here. We've got a woman and she is looking up at looks like a kite maybe, or a hang glider. And it's 38 degrees from straight out ahead of her to that hang glider. And that is considered the angle of elevation. Similarly, we have what's called an angle of depression. And that's the angle formed by a horizontal line and the line of sight to an object below the horizontal line. So similar type of concept, but instead of raising your head up, it would be like looking down. Typically, we do this with things that are in the air. We might talk about an airplane's angle of depression from where they're at looking down. So again, start with the horizontal line and create an angle of depression that goes down. So here, oops, missed my words. The angle of depression is this 38-degree angle here from that hang glider looking down until the object, which would be that lady. So let's just practice identifying those two types of angles. We want to ask for a description of the angle. It relates to each of these angles listed here, 1 through 4. So let's start with angle 1, and it looks like angle 1 is from this maybe a bird up here, and it's looking down to the person inside the hot air balloon. We start at the horizontal, which is this dotted line, and we're going down. That means angle 1 is an example of an angle of depression. Starting at the horizontal and going below. Angle 2 now is this angle created from the horizontal coming out from the person inside the hot air balloon, looking up to the bird that's in the sky. When we go from a horizontal up, we call that an angle of elevation. So 2 is our angle of elevation. Angle 3 uses that same horizontal that angle 2 did, but now the person inside the hot air balloon is looking down to the base of this mountain. So from a horizontal down, we call that an angle of depression. So angle 3 is another angle of depression, just like angle 1. And our last angle here, angle 4, the horizontal looks like it might be the sea or the plains out from this mountain and looking up from that mountain. Anytime we go horizontal up, we're talking about an angle of elevation. So this picture here has 4 angles, 2 of which are angles of depression, 2 of which are angles of elevation. Remember, the key feature here is to take your horizontal from where you're looking and either go down or up. Down is depression, up is elevation. So let's practice putting that into play here. It says, suppose you stand 53 feet from a wind farm turbine. Your angle of elevation to the hub of the turbine is 56.5 degrees. Your eye level is 5.5 feet above the ground. Approximately how tall is the turbine from the ground to its hub? So there's a lot going on in this problem. So let's break it down piece by piece. They've given us a nice picture here. And we can see here our man is looking up to the hub. That's the center of that turbine. And that angle of elevation here is a 56.5 degree angle. And we know he's standing 53 feet. So we're asked to find how tall the turbine is from the ground to its hub. So that distance is actually all of this. We're going to call that h. But in order to find h, we need to first find x. So let's find x using SOHCAHTOA, and then we'll continue on the problem to actually solve it, finding h. Now, let's look at what we know. Our angle of elevation is what's given. So I know this angle here, 56.5. That's the angle I'm going to use when using SOHCAHTOA. So notice here, this x is the side that I didn't highlight, so that becomes my opposite. And 53 is not my hypotenuse, making it then the adjacent side. So remember our SOHCAHTOA shortcut, and I'll list it here for you. We need to figure out which of those sine, cosine, or tangent, which of those trig functions we're going to use to identify x. I'm looking for the opposite, and I know the adjacent. So the trig function that uses opposite and adjacent is tangent. So I'm going to set up a trig function using tangent. And I'm going to say tangent of 56.5 is equal to opposite, I don't know, so that's x, over adjacent, which is 53 feet. And now I need to solve for x. So I'm going to put my tangent over 1, cross multiply, and I get x is equal to 53 times tangent of 56.5. So we've practiced this in section 3. Make sure you have a calculator that can calculate trig functions, and make sure that you're in degrees. And let's go ahead and throw this into our calculator. 53 times, in my calculator, I put the 56.5 before I click tangent. Yours may be different. Just make sure you're familiar with what you're using. And then always make sure you go ahead and hit enter. So x is equal to about 80.07. And if we were just looking for x in this problem, we could stop there. But remember, we talked about in the beginning, we're actually not just looking for x, we're looking for that whole height of the base of the turbine from the center to the ground. So the other piece of information we haven't talked about yet is this sentence here that says your eye level is 5.5 feet above the ground. That means that from where this man is looking to the ground is 5.5 feet. So notice what I'm looking for here, the height, is x plus how tall his eye level is. So the height is going to be equal to the length of x plus the man's eye level. So since I know both of those, I can find the height by doing some substitution. X is about 80.07, and his eye level is 5.5 feet. So the total height is going to be the sum of those two values, which is 85.57 feet. Approximately, since we did have to round to find x. So my final answer here is that the height of that wind turbine is about 85.5 feet tall. When you're given and you're looking for a total height and you're starting at eye level, make sure that you consider how tall that eye level is, and you'll be given that information in the practice problems. So let's practice one more of those. It says you sight a rock climber on a cliff at a 32-degree angle of elevation. Your eye level is 6 feet above the ground, and you're approximately 1,000 feet from the base of the cliff. What is the approximate height of the rock climber from the ground? So again, a lot of information here. They did provide us with a picture, which helps a lot. Let's talk about where those values come from in this picture. We're told a 32-degree angle of elevation. So from his eye level, horizontal and up creates this 32-degree angle. What we need to include in here is the fact that this is somebody's line of sight. So from their eye level, 32 degrees up. The other piece that we know is that your eye level is 6 feet above the ground. So this person stands just over 6 feet tall. Now, they've told us that they're standing 1,000 feet away from the base of the cliff, and we want to know the approximate height of the climber to the ground. So the climber's here, and from eye level is here. We're going to call that x, but what we're looking for is the height from the top of the climber all the way to the ground. So we're going to need to include that extra step, just like we did in the previous problem, that accounts for the height of the eye level off the ground. But again, let's start by just finding x, and then we can continue on to find h. So x, this is my angle, x again is my opposite, 1,000 feet is my adjacent. So once again, I'm going to use the trig function that utilizes tangent, or excuse me, uses opposite and adjacent, which is tangent. So I'm going to set up my SOHCAHTOA tangent of 32, TOA, opposite over adjacent, x over 1,000. Again, cross multiply to solve, put tangent over 1, we get x is equal to 1,000 times tangent of 32. And make sure you're practicing these on your calculator so that you can do them when you get to the homework. And we get about 624.9 for a value of x. But again, we're not done there. That's the distance from the climber to that person's eye level. We want to know the distance from the climber all the way to the ground. And since that viewer is 6 feet from the ground, our total height is going to be the height of x plus the 6 feet that our person stands from eye level to the ground. So again, substitution, x is 624.9 plus 6, and we get about 630.9, or you could round that up to 631 feet the climber is from the ground. So again, just make sure you're reading your question. There will be times where it doesn't include the height of the eye level, and that's okay. Then you can just quit once you find the value of x. Make sure that you're reading your problem thoroughly and answering the question it's looking for. So those are two problems that dealt with angle of elevation, and that tends to be a little bit simpler than angle of depression. We usually need to include at least one extra step when working with angle of depression, and sometimes more. So let's go ahead and give it an angle of depression example a shot. It says to approach runway 17 of the Panoka City Municipal Airport in Oklahoma, the pilot must begin at a 3-degree descent, starting from a height of 2,714 feet above sea level. The airport is 1,007 feet above sea level. To the nearest tenth of a mile, how far from the runway is the airport to the start of the approach? At the start of this approach. So we have a lot going on here. Let's start with the height of that plane where we're beginning. And it says the airplane is 2,700 feet above sea level. But that doesn't mean that he's 2,714 feet high, because the airport actually isn't at sea level. The airport is 1,007 feet above sea level. So to find the actual height of that airplane from where it's at flying to the airport, we're going to have to take that 2,714 feet and subtract the feet above sea level that our airport is, which is 1,007 feet. That tells us that the airplane is actually 1,707 feet above the airport. So we do have a picture here, but I'm going to go ahead and set up a different picture where I can kind of include a little bit more information. Oops. So I'm going to start with my airplane and ignore the fact that this is quite ugly. Well, that doesn't even look. How about that? Okay, there's my airplane. And we just said, hey, that airplane is 1,707 feet above the airport. And now we also know that this airplane has an angle of depression, since he's going on his descent, he's going down from the horizontal down, is 3 degrees. Now, if you notice, I've got the starts of a right triangle here. I'm going to create this triangle using the ground and the airport. So notice I do have a right angle, but that 3 degrees isn't actually inside the right triangle. But what we can use is the fact that this horizontal out from the airplane and the ground are parallel lines. That makes this line, the angle depression line, a transversal, and that makes this angle congruent to the 3-degree depression. So we do have that extra step built in there when we're talking about angle of depression to move that angle of depression from outside the triangle using alternate interior angles to inside the triangle. And it should always work that way. So now the final thing I have to do is figure out what I'm asked to find so that I can use SOHCAHTOA to do it. And if you read here, we're asked to the nearest tenth of a mile, how far from the runway is the airplane at the start of the approach? So how far is this airplane from the runway, which is this horizontal down here? So I'm actually looking for the hypotenuse in this case. This is the first time we've seen that in this lesson. So the angle I know is here, this 3 degrees. The 1707 is my opposite side, and x is my hypotenuse. So if we remember SOHCAHTOA, which which trig function uses opposite and hypotenuse? That would be sine. So we're going to set up using sine. Sine of 3 degrees equals opposite, which is 1707, over hypotenuse, which is x. Take your trig over 1, cross multiply, x times sine of 3 equals 1707, and divide both sides by your sine 3 to get x by itself. And x is approximately 1,707 divided by sine of 3. Let's see what that is. 1707 divided by, and again, 3 sine, and enter. About 32,616 feet. But be careful. This problem is really involved. If we go back to what I underlined there in purple, it doesn't just want my answer in feet. It says to the nearest 1/10 of a mile. So I actually have to convert my 36,616 feet into miles. And if you remember your conversion factor, there are 5,280 feet per mile. So I'm going to take that value of x that I found in feet, divide it by 5,280 to get my answer in miles. So the nice thing about this calculator I have is if I just click divide right now, it's going to take that full answer as it was. Try not to round in this step until the very end if you can. So I'm going to take that, divide it by 5,280, and now it wants me to round to the nearest 1/10 of a mile. My plane is approximately 6.2 miles, approximately, from the airport when it begins its descent. So like I said, the angle of depression problems tend to be a bit more involved. We've got one more example. It's not quite as many steps, so let's go ahead and take a look at that, and we will practice angle of depression again. An airplane pilot sights a life raft at a 26-degree angle of depression. The airplane's altitude is 3 kilometers. What is the airplane's horizontal distance from the raft? Now, this is the first time we haven't been given a picture, so we're going to have to draw our own picture. I would never recommend approaching your homework problems that don't have pictures without drawing one yourself. It's a lot to kind of do in your head and a lot to sort out in your head. So get out some scratch paper or your notebook where you keep your notes, or the back of these notes, however you want to do that. And make sure that you're drawing pictures as you approach your homework problems. So let's see here, what do we know? An airplane's pilot's sights a light raft at a 26-degree angle of depression. So here's my airplane pilot. Angle depressions start with the horizontal and go down. That's telling me that that is 26 degrees. That's the first sentence. The next sentence says that the airplane's altitude is 3 kilometers. That means from the ground to the airplane, it's 3 kilometers, which is going to be like this vertical distance here. So now I need to figure out what part of this triangle, and we can go ahead and make that a triangle, and my right angle there, am I trying to find? It asks for the airplane's horizontal distance from the raft. So my raft is down here, the horizontal distance is along the bottom here, and we're going to call that D. So in this case, I'm looking for D. Now again, if you look at that triangle, the right triangle, the 26 degrees does not fall inside the triangle. But using alternate interior angles, I can state this angle is also 26 degrees. Now, let's set up our trig function using SOHCAHTOA. 3 kilometers is opposite. The D that I'm looking for is adjacent. So which trig function uses opposite and adjacent? We're going to choose tangent. We're going to say tangent of 26 equals opposite, which is 3, over adjacent, which is D. And cross multiply. D times tangent of 26 equals 3. Oops, and I wrote a 3 there instead of a 6. To get the D by itself, we're going to divide both sides by tangent of 26, which tells us that D is equal to 3 over tangent of 26. Let's do that division. 3 divided by 26, tangent, and enter, about 6.2 kilometers. So what did we just find? We just found that this horizontal distance is about 6.2 kilometers. So again, if you're not given a picture, always take the time to draw that picture out. It's going to probably save you from a lot of just little mistakes. If you have any questions, please let me know.